6/2 H2O gas. And now we'd have to go and take our delta RHM and multiply it, our negative 483.6 kilojoules times 3/2. And this would actually just be equal to 3. For a second part, we'd see that we need a carbon monoxide gas. And so we'd look through and see where we can find a carbon monoxide gas. And we realize that it is in our second formation. But we only need 1 mole where they have 2. So we'd take, and we'd also need to reverse it. So we go 1/2 times negative. And we'd go CO gas form C solid plus 1/2 O2 gas to form delta RH is equal to negative 221.0 kilojoules times 1/2. Now we need methane. Oh, I forgot to write the 4. So for methane, we're going to look at our third formation, and we realize it's already on the same side and the same amount of moles. So we go just simply CH4 gas plus 2O2 gas to form CO2 gas plus 2H2O. And keep our same combustion for negative 802.7 kilojoules. And we'd be timesing this by 1. Lastly, we need H2O on the end. And we already have H2O on the end. Now we see our mistake. CH4 is actually a product, so we need to reverse this one. So cross out this entire thing. Sorry, my mistake. CO2 gas plus 2H2O to form CH4 gas plus 2O2 gas. And so all we did is reverse it, and so that we can have methane as a product, not like here, methane being a reactant. Because we need this to be a product. Sorry, I was just kind of looking over the work. So the fourth we need is, and you're looking and you're saying, well, we already got H2O. Why do we have this fourth reaction? And it is to cross out the amount of CO2s we have on each side. So we'd have C solid plus O2 gas to form CO2 gas. And so we'd be actually timesing this by 1, just so that once we put it all over in an equation and add these guys all up, we'd be able to cross out our CO2s and our carbons and our O2s. So we'd have 393.5 kilojoules. So now we can start crossing out. So CO2 gas, or that's a CO gas. Very important you realize the difference between carbon monoxide and carbon dioxide. Cross this out. Sorry. C solid, O2 and O2. We only have half here. Might become a problem, but we'll play it out. Oh, what happened here was this was supposed to be a 1. It was already a 2, and you had to 1/2 it. That cancels, and we're left with 3H2. Oh, and this cancels as well. There we go. 3H2 plus 2H2O. Oh, we got H2Os that cancel as well. We have 3 here, 2 here, 2 cancels, 1 is left. There, this is really sloppy. Leaving you with 3H2 plus CO, carbon monoxide, here, here, to form methane, CH4 gas, plus H2O, 1 mole. And lastly, we're done with that, and now we're going to look at these guys and calculate what our delta RH is. Negative 483.6 times 3/2 plus negative, or let's just say positive, 221.0 times 0.5 plus a positive 802.7 minus or plus a negative 393.5 kilojoules, all equaling to negative 205.7 kilojoules. Well, that's a lot of work. And now what we're going to do is use the shortcut of Hess's law, and we'll use the exact same question that we used for number 4. So number 4 is again 3H2 gas plus carbon monoxide to form CH4 plus H2O gas. We're going to find our delta RH by using Hess's law. Kind of skip, quick way of doing it, and that is by timesing it per molar enthalpy of products times delta RHMs minus the reactants times delta RHM is equal to delta RH. And so we're actually going to double check that we got this right, or negative 205.7 kilojoules. So, of our products, we're going to use our formula sheet, and that is on page 4 and 5, and we're going to try to find carbon monoxide. And carbon monoxide is found right here, negative 110.5 kilojoules. So negative 110.5 kilojoules per mole times 1 mole, so the moles cancel, all under a big box, so moles cancel, plus 1 mole of H2O gas. It's very important to see if it's gas or liquid H2O, because there's a big difference. There's negative 285.8 and negative 241.8. And for gas, it would be times negative 241.8 kilojoules. And this is mole. Minus our reactants. Now, 3 moles of H2, you're going to look through here and realize that for some reason it's not here. And that is because, actually, all elements we say to have a 0 molar enthalpy. And that's just kind of the whole idea. It's not, when you go into university, it is not, it's pretty close to 0, but sometimes it might not be 0, but we like to say it's pretty close, and so we show it as 0. So in a big box, 0 moles times 0 kilojoules per mole plus 1 mole of carbon monoxide. Uh-oh. This is supposed to be here, negative 110.5 kilojoules per mole. And this is our methane. Methane is right here, negative 74.6 kilojoules per mole. Hopefully that didn't confuse you. So products minus reactants, we're going to go and calculate that now. So that's negative 74.6 plus negative 241.8 minus negative 110.5. And I bet that's going to equal negative 205.7. And survey says, oh, we're off by a digit, 2 digits. Methane, 74.6, 74.6, 241.8, 241.8, and that is weird. Carbon monoxide, 110.5. Okay, let me just calculate this one more time. Negative 74.6 plus negative 241.8 minus negative 110.5. I don't know what to say, but negative 205.7 is supposed to be your answer. Oh, it was just a digit problem, so it's actually negative 205.7. Still trying to figure out where the mess up was, but anyways, moving on. We can do one more Hess's law shortcut way. And how will we do that? for the first question we did before. So the H2O plus carbon to form carbon monoxide and H2. And we can verify this answer. So products minus reactants. And we're going to take our products, which is carbon monoxide, we already know that, to be negative 110. So negative 110.5 kilojoules per mole times 1 mole plus hydrogen gas, which is 0, minus H2O gas, which is H2O vapor, negative 241.8 by 1 mole. Now this should be equal to 131.3. So negative 110.5 minus negative 241.8 is equal to 131.3 kilojoules. And so that is the Hess's law way, and this is the shortcut to just find any delta RH very quickly. And that's it for guide 3. And for guide 4, we'll go into a bit of catalyst. Thanks.